Hey everyone, let's talk about transcription translation. This is not going to go in details. In details, you have a lot of videos already in the Blackboard. I just want to give you an overview of all of those transcription translation processes, and most importantly, the contrast. You want to be able to talk about them independently, but also compared to each other. First thing first, though, hope you remember DNA bases. It's going to be ATCG. Right? If you talk about RNA, that's going to be AUCG. Just making sure we're on the same page. Those are the nucleotide. It's going to be ATCG or AUCG. So if you have a U, you know it's RNA. If you have a T, you know it's DNA. If you have A, C, and Gs and you don't see any U's or T's, you don't know, or do you? DNA is double-stranded, 2 strands. RNA is single-stranded, 1 strand. Okay? So that's for the little backup information. Okay, let's get started. Okay, so the cooking analogy that I use in the PowerPoint is extremely good for several reasons. So keep that in mind. The cookbook is your DNA in transcription. That's when you copy a page of a book into a recipe. Because we have cookbooks from our grandmas, and if you have a good recipe in there and you want to pass it on to a friend, you're not passing the book. You don't let the book leave your site. You give them a copy of a recipe. The translation, on the other hand, here, it's all when you get all the cooking ingredients, so amino acids, the tRNA, the ribosomes, all those together, and you're going to translate that cooking. You're going to literally read the cooking recipe and make proteins out of that. Okay, so in transcription, if you take a look at your cell, and you have the nucleus in there, transcription, it's all in the nucleus, right? So let's make our nucleus. Let's imagine we're going to zoom in the nucleus, and we're going to say this is a nucleus now, right? Nucleus, you have a DNA, double-stranded pieces of molecule, and it's all about going to single-stranded molecule. And you have to get the copy to a single strand. And why? The main reason is, remember that nucleus, they have nucleopore. And the key about the DNA is it's hiding in the nucleus, it's protected and cannot leave because it's too big to pass through the spores. But you need the information to get out. And RNA is small enough to get through. So RNA will make its way out, right? Translation, on the other hand, if you make your cell and you make your nucleus here, and we're going to make little openings again, those nucleopores. Once you have your RNA that can leave, right, it's all about getting that RNA to a ribosome that will be able to read the RNA. So the ribosome is in 2 units, and synthesize out of it a protein, right? And the protein just comes out of the ribosome. Remember that protein is simply primary structure at that point, right? Hasn't gone to the endoplasmic reticulum to get folded, secondary structure, tertiary structure, and quaternary structure. And of course, to get that whole thing working, you need to have tRNAs that are bringing those amino acids, and amino acid being the little beads, and they bring them one by one and leave the tRNA, get pushed out without the amino acid, but get reattached to other amino acids that are just floating around. The key is, why do you need those amino acids to be on the tRNA? It's because we're reading the code in translation, right? So transcription is just copying with some variation, T to U, remember that? Right? T becomes U. Whereas in translation, we're actually translating from a code to another. The code being the RNA codons, 3x3 nucleotide bases, nucleotides, and you're reading those via the ribosome against tRNA, bringing the corresponding amino acids. So a little bit of foreshadowing. So this is the ribosome. A little bit of foreshadowing for following videos. I'm not getting into the detailed transcription here, neither translation here. I'll just try to go a little overview in 2 more videos. I'll talk about what happens in the processing of RNA after it's been synthesized via transcription before it gets to the ribosome in terms of how you control that process, because that's really important for regulation. Okay, that's all for just this video. That's just an overview. So remember, transcription in the nucleus, right? Really important. Transcription in the nucleus because you're transcribing. Think about monks copying book to another one. They copy a book to a page, and that's transcription. Then once you transcribe, the language in which it's transcribed is the same language. But now you need to translate that language because you want to go from a DNA language, RNA language now, into a protein language. And to do that, you need to translate, and that's when you use the big codon table. Okay, that's all for today, and see you in another video.